The Roman Empire, an engineering legacy that shaped civilization. In the dawn of history, when Europe was still in the slumber of primitive ages, a civilization emerged that forever transformed the concepts of construction and engineering. Rome was more than just the capital of a vast empire. It was a colossal engineering laboratory that devised technological solutions whose secrets we are still trying to decipher today. That civilization turned stone and lime into architectural marvels defying time, paved smooth roads across 3 continents, and created complex hydraulic systems centuries ahead of their era. Aqueducts, engineering mastery. Over water was the lifeblood of civilization, and the Romans understood this profoundly. Their aqueducts were not mere channels, but hydraulic wonders governed by precise physics. They built intricate networks of elevated conduits that carried water from mountains to cities, conquering rugged terrain with the boldness of engineers, who designed lead pipes and towering stone arches spanning vast distances. Structures like the Pont du Gard in France still stand as a testament to their brilliance, with gradients calculated to ensure smooth water flow without eroding the stone. Roman concrete, the secret of eternal construction. The Pantheon, that majestic temple with its soaring dome, would not have endured for over 2 millennia without Rome's greatest invention, concrete. It was not just a mix of stones and lime, but a secret recipe incorporating volcanic ash from Pozzuoli, giving it strength that increased with time rather than deteriorated. The Romans understood material chemistry in ways that remain mysterious, allowing their structures to withstand earthquakes and wars while modern buildings crumble after mere decades. Roads, the empire's lifelines. All roads lead to Rome was not just a poetic phrase, but a tangible reality. The Roman road network, stretching over 400,000 kilometers, was the ancient world's internet, transporting generals, messages, and goods with astonishing speed. These were not dirt paths, but layered constructions of gravel and tightly fitted stones engineered to prevent cracks with sloped sides for drainage. Some, like the Via Appia, still exist today, bearing the marks of chariots that rolled over them centuries ago. Military technology, war machines that changed history. The Roman army was not just soldiers in gleaming armor, but a technological marvel. From the ballista, hurling stones weighing hundreds of kilograms, to the Helepolis, massive siege towers that overwhelmed fortifications, the Romans engineered tools of conquest. Even their personal weapons, like the gladius, short sword, and pilum, heavy javelin, were refined through years of study to maximize battlefield efficiency. Civil engineering, where architecture meant philosophy, Rome was no ordinary city, but an architectural masterpiece. Underground sewers like the Cloaca Maxima, circular amphitheaters like the Colosseum seating 50,000 spectators, and public baths with advanced hypocaust heating systems, all showcased how Romans saw technology as a means to human prosperity. Agriculture and machinery, the empire's hidden economy. Even in fields, Roman ingenuity thrived. They invented the iron plow, advanced water wheel irrigation, and water mills that revolutionized grain processing. They transformed farming from backbreaking labor into a precise science, feeding millions across the empire. A legacy that never died. When Rome fell, its technology lived on. Building techniques influenced the Middle Ages, road networks became the foundation for modern highways, and urban planning concepts inspired European cities. Today, walking on paved roads, drinking clean tap water, or seeing earthquake-resistant skyscrapers, we witness echoes of Roman genius that shaped the world as we know it. Rome was more than an empire. It was a technological revolution. And its legacy is not just ruins, but an eternal idea that true progress serves humanity and endures through time. The Roman Empire, an engineering legacy that transformed civilization at the dawn of history. While Europe slumbered in primitive times, a civilization arose that forever altered the concepts of construction and engineering. Rome was far more than just the capital of a vast empire. It was a colossal engineering laboratory that devised technological solutions whose secrets we are still striving to comprehend today. This was the civilization that transformed stone and lime into architectural marvels defying time, paved smooth roads across 3 continents, and created intricate hydraulic systems centuries ahead of their era. Roman architecture was not merely about massive stone structures, but a comprehensive philosophy of utilizing space and mass. Roman engineers understood that greatness was not measured by a building's size alone, but by how harmoniously it served human needs and aligned with nature's laws. The famed dome of the Pantheon, weighing thousands of tons, was not a burden on its supporting walls, but a precise mathematical masterpiece, with loads intelligently distributed through a series of hidden internal arches. This dome remained the world's largest unreinforced concrete dome for centuries, unchallenged. The Roman road network was not just a means of travel, but a fully integrated nervous system connecting the far-flung reaches of the empire. Each road was an independent engineering project, beginning with a foundation layer of large stones, followed by successive layers of gravel and sand, and culminating in a surface of tightly fitted stone slabs. Carefully calculated side slopes, drainage basins, and regular relay stations along the routes all testify to an advanced, methodical mindset in planning and execution. In water management, the Romans achieved a level of mastery unprecedented in their time. Aqueducts were not mere channels for transporting liquids, but complex hydraulic systems that calculated gradients with extreme precision. Roman engineers developed techniques for measuring water levels using sophisticated surveying tools and invented control valves and multi-layered filtration systems. Some aqueducts, like the one in Segovia, Spain, still function today, 2,000 years after their construction, standing as testaments to the durability of their design and the precision of their execution. Roman military technology was another tale of creativity and innovation. Siege engines were not just tools of destruction, but mechanical marvels combining power and precision. The Roman ballista could hurl stones weighing 80 kilograms over distances exceeding 500 meters, with remarkable accuracy. The mobile siege towers known as helepolis were fully equipped wheeled fortresses, complete with multi-level platforms for soldiers and archers. Even individual weapons like the Roman javelin, the pilum, were refined through years of study to become unstoppable piercing weapons. In construction, the Romans introduced the world to a revolutionary concept of concrete. Their secret mixture was not merely cement and stone, but the product of centuries of experimentation in material chemistry. The addition of pozzolana volcanic ash from the Pozzuoli region gave Roman concrete a unique property. Its strength increased over time rather than diminished. Structures built with this concrete withstood earthquakes and weather for centuries, while modern constructions deteriorate after just a few decades. The Roman sanitation system was centuries ahead of its time. Sewer networks beneath cities like Rome's Cloaca Maxima were integrated systems with main and subsidiary channels, complete with inspection ports for periodic maintenance. Roman public baths were not merely places for washing, but comprehensive recreational complexes featuring advanced hypocaust underfloor heating systems, where hot air circulated beneath floors and within hollow walls to ensure even heat distribution. In agriculture, the Romans developed advanced techniques to boost productivity. The villa agricultural system was a model of scientific land management, employing crop rotation and advanced tools like wheeled metal plows. Roman water mills were mechanical marvels combining hydraulics and mechanics, capable of grinding grain in large quantities to meet the needs of growing cities. Roman maritime technology was astonishingly advanced. Massive ports like Ostia were built using special underwater concrete techniques. Roman ships were equipped with sophisticated sailing systems, including primitive astronomical navigation tools and advanced sail-raising mechanisms. Roman shipbuilding techniques enabled the creation of vast commercial and military fleets, connecting the empire's distant regions. In mining, the Romans developed advanced techniques for mineral extraction. Mines like those at Rio Tinto in Spain utilized sophisticated systems for water drainage and tunnel lighting, along with advanced smelting and refining methods. Roman mining tools such as pickaxes and hammers were continuously improved to enhance productivity. Roman medical technology saw significant advancements, particularly in surgery. Discovered Roman surgical instruments reveal precision craftsmanship and mechanically advanced designs. Medical texts by Roman physicians like Galen contained pharmaceutical recipes and treatment methods that remained standard in Europe until the Renaissance. Roman measurement systems formed the basis for many modern standards. Units like the Roman foot and Roman mile were calculated with extreme precision, and used in construction projects and road networks across the empire. Roman measuring tools like the groma, surveying instrument, and water levels were precise, instruments that ensured the quality of massive construction projects. Roman heating technology was remarkably advanced. The hypocaust underfloor heating system was not merely a heating method, but an integrated temperature control network of channels beneath floors and within walls. This system was used in public baths, palaces, and luxury homes, demonstrating a profound understanding of hot air dynamics and distribution methods. In communications and transportation, the Romans developed an advanced postal system, the cursus publicus, capable of relaying messages across the empire at astonishing speeds. For the time, regularly spaced relay stations along major roads allowed urgent messages to travel up to 800 kilometers per day using a courier rotation system. Roman glassmaking saw major advancements with transparent glass produced on a large scale for the first time. Roman glass-blowing techniques enabled mass production of affordable glass vessels, making glassware accessible to the middle classes. In arts and decoration, the Romans developed advanced mosaic and fresco techniques. Roman fresco pigments were created with special chemical compositions that preserved their vibrancy for centuries. Roman sculpting techniques achieved remarkable precision in anatomical details and facial expressions. Roman educational technology was notably advanced. The Roman school system followed structured, graded curricula, using teaching tools like wax tablets and scrolls. Major Roman libraries, such as the Library of Trajan, featured sophisticated cataloging systems for manuscripts and documents. In 90s, entertainment, Roman amphitheater, and theater construction was an engineering marvel. The Colosseum in Rome could accommodate over 50,000 spectators, with an integrated entry and exit system via vomitoria passages that prevented crowding. Lighting and acoustics in these venues were carefully designed to ensure an optimal spectator experience. Roman legal and administrative technologies laid the foundation for many modern systems. Roman record-keeping and documentation systems were remarkably advanced, employing wax seals and sophisticated classification methods for official documents. Roman textile technology saw significant progress, with diverse fabrics produced from wool, linen, and silk. Roman factories, or gynecia, could mass-produce high-quality fabrics using advanced looms. In food preservation, the Romans developed advanced techniques like pickling, drying, and smoking. Roman granaries, or horia, were marvels of storage, featuring advanced ventilation systems to prevent mold and spoilage. Roman musical technology was sophisticated, with complex instruments like the water organ powered by hydraulic pressure. Roman musical theories formed the basis for many later musical systems. In astronomy and calendar systems, the Romans developed the precise Julian calendar, which became the foundation for the modern Gregorian calendar. Roman astronomical observation. Tools allowed accurate calculation of dates and religious festivals. Roman defensive technologies in wall and fortress construction were remarkably advanced. Hadrian's Wall in Britain was a comprehensive defensive system with watchtowers, small forts, and internal roads for rapid troop movement. In ceramics, the Romans developed advanced techniques for producing decorated terra sigillata pottery, using high-temperature kilns that maintained consistent heat. Roman ceramic products spread throughout the empire and beyond. Roman chemical technologies in soap, dye, and perfume production were advanced. Soap-making recipes using animal fats and ash were widely known and used. In financial engineering, the Romans developed a primitive banking system using deposit certificates and monetary transfers between provinces. The Roman tax system was sophisticated, relying on accurate population and resource statistics. Roman mathematical technologies in calculation and geometry underpinned many practical applications in construction and trade. The Roman abacus, or calculi, simplified complex arithmetic for accounting and administration. In animal husbandry, the Romans developed advanced techniques for breeding horses and pets, with sophisticated veterinary care and selective breeding systems. Roman fish farms utilized integrated water circulation and feeding systems. Roman firefighting technology was advanced, with organized vigils brigades equipped with primitive water pumps and early fire alert systems. In paper production, Romans widely used papyrus, developing processing techniques to enhance its durability and longevity. The Roman codex book format marked the beginning of the modern book. Roman military signaling technology was advanced, employing smoke signals and light signals to rapidly relay messages over long distances. Roman optical telegraph systems allowed swift transmission of military intelligence. In jewelry making, the Romans developed advanced gold and silversmithing techniques, using various gemstones and intricate inlay methods. Roman jewelry was renowned for its precision and beauty. Roman theatrical technology included complex mechanisms for changing stage scenery, systems for raising and lowering actors, and machines for producing sound effects. Roman theaters featured advanced acoustics ensuring clear audibility from all seats. In personal weaponry, the Romans developed advanced metal hardening and heat treatment techniques to enhance sword and spear durability. Roman arms factories could mass-produce standardized military equipment. Roman diplomatic technologies for managing foreign relations were sophisticated, featuring precise treaty systems and protocols for real-time translation in official meetings. In footwear and military clothing, the Romans developed advanced techniques for producing caligae marching boots and chainmail armor that balanced protection with mobility. Roman urban planning technologies were advanced, featuring the Hippodamian grid street system, water, distribution and sewage networks, and designated zones for housing, commerce, and entertainment. In household tools, the Romans developed advanced metal and glassware production techniques with practical yet aesthetic designs. Roman kitchen tools were sophisticated, including many precursors to modern utensils. Roman commercial technologies for pricing and quality control were advanced, featuring standardized measurement and calibration systems and consumer protection against fraud. In furniture making, the Romans developed advanced carpentry and metalworking techniques, producing pieces notable for both design and function. Roman furniture was renowned for comfort and decorative beauty. Roman athletic technologies in gymnasium and pool construction were advanced, featuring heated winter pools and architectural designs accommodating various exercises. In surgical tools, the Romans developed a comprehensive set of precision instruments, many of which remain in use in evolved forms in modern surgery. Roman medical texts contained precise instructions for manufacturing and sterilizing these tools. Roman statistical technologies for census and vital records were advanced, with accurate records used for military and civil planning. In timekeeping, the Romans developed sophisticated water clocks, or clepsydra, used in courts and public baths, featuring complex water flow regulation for precise time measurement. Roman environmental technologies for natural resource management were advanced, with laws protecting forests and mining areas, and systems for water recycling and multi-purpose use. In toys and home entertainment, the Romans developed various board games and mechanical dolls, with advanced techniques for simple mechanical toys. Roman linguistic technologies in developing and spreading Latin formed the basis for many modern European languages. Roman language education was methodologically advanced. In writing tools, the Romans developed metal-nibbed stylus pens and wax tablets, with advanced ink and paper production techniques. Roman psychological technologies for understanding human behavior and crowd management were advanced, evident in amphitheater design and mass event organization. In hunting tools, the Romans developed advanced nets and animal traps, with sophisticated meat and fish preservation techniques. Roman ceremonial technologies for organizing processions and festivals were advanced, featuring decorated floats, large musical instruments, and nighttime lighting using oil lamps. In construction tools, the Romans developed a comprehensive set of specialized carpentry, building, and architectural drawing tools, with advanced sharpening and maintenance techniques. Roman media technologies for disseminating news and advertisements were advanced, using public inscriptions and town criers. In maritime rescue tools, the Romans developed primitive lifeboats and life rings, with techniques for distress signaling using mirrors and fires. Roman insurance technologies for maritime trade protection were rudimentary but effective, with systems compensating merchants for goods lost in storms or to piracy. In precision measurement tools, the Romans developed advanced rulers and water levels, with techniques for calibration and maintenance. Roman cosmetic technologies for perfumes and makeup were advanced, using herbal mixtures and aromatic oils in skincare and beauty products. In pharmaceutical tools, The Romans developed precise scales for measuring medicinal ingredients and compounding tools, with advanced drug preservation techniques. Roman music therapy technologies for healing were advanced, with theories on how different melodies affected patients' mental and physical states. In folk craft tools, the Romans developed simple musical instruments and traditional costumes, preserving local customs across provinces. Roman home entertainment technologies included board games and folk tales, with techniques for making simple wooden dolls and toys. In astronomy and weather prediction tools, the Romans developed simple instruments for star observation and weather forecasting, relying on generational knowledge. Roman food technologies for preservation and storage were advanced, using salt, vinegar, and oil for meats and vegetables, and fermentation techniques for cheese and pickles. In personal hygiene tools, the Romans developed nail clippers and primitive toothbrushes, using natural ingredients for soap and toothpaste. Roman evening entertainment technologies included poetry and music gatherings, with techniques for lighting banquet halls using oil lamps and candles. In gardening tools, the Romans developed specialized pruning and planting implements, with advanced landscaping and irrigation techniques. Roman seasonal technologies for agricultural festivals were advanced, with precise calendars for planting and harvest-related holidays. In art tools, the Romans developed paintbrushes and mineral pigments, with advanced dye and adhesive production techniques. Roman vocational training technologies were advanced, with apprenticeship systems ensuring craft quality across generations. In home pharmacy tools, the Romans developed dosage measuring devices, with guidebooks for simple home remedies. Roman military music technologies using trumpets and rhythms were advanced, with specific musical signals for different commands. In religious folk tools, the Romans developed protective amulets and necklaces, with elaborate rituals for sacred ceremonies. Roman winter entertainment technologies included indoor games and house parties, with heating and lighting techniques for cold seasons. Empire of Geniuses, the complete narrative of Roman civilization. From the Stone Age to technological zenith. In the dawn of time, when Europe languished in primitive darkness while great Eastern civilizations flourished, began the story of history's greatest empire. Rome was not merely a city born on the Tiber's banks. It was an idea made flesh, an engineering dream transformed into tangible reality. Every stone in its streets, every water channel beneath its soil, every road spanning continents told the story of a human mind that transcended its era. Let us begin our journey with that majestic Pantheon dome, still standing proud 2 millennia after its construction. This dome is not just architecture, it's a mathematical equation made physical, a physics masterpiece centuries ahead of its time. Roman engineers, without computers or modern measuring tools, calculated stress distribution with astonishing precision, inventing the hidden arch system supporting enormous weights invisibly. It's not merely a dome, it's testament that human genius knows no bounds. The Roman road network presents another breathtaking marvel. Imagine these weren't simple dirt paths, but an integrated system like living veins. Each road tells a story of meticulous design, from foundational layers of large stones, through successive gravel and sand strata, to surface slabs fitted like puzzle pieces. Calculated side slopes, drainage basins, regular rest stations, all reveal an advanced systematic mentality that makes us wonder, how did they achieve such precision without any modern technology? In water management, Romans reached perfection levels that still awe contemporary engineers. Their aqueducts weren't mere channels, but complex hydraulic systems calculating gradients to thousandth degree precision. They used advanced surveying, tools to measure water levels, invented smart control valves, and multi-layer filtration systems. Some, like Segovia's famed aqueduct, still function today after 2,000 years, enduring proof of unparalleled craftsmanship. Roman military technology composed another epic of innovation. The ballista wasn't a primitive weapon, but a mechanical masterpiece hurling 80-kilo stones over 500 meters with pinpoint accuracy. Mobile helipolis siege towers were complete wheeled fortresses with multi-level combat platforms. Even individual weapons like the pilum spear resulted from years of research and development for battlefield perfection. In construction, Romans gifted humanity an invaluable legacy: Roman concrete. This miraculous material wasn't just cement and stone mix, but a magical formula discovered through centuries of experimentation. Adding Pozzuoli's volcanic pozzolana ash gave concrete a unique property, strength increasing over time rather than deteriorating. This explains why the Pantheon and Roman monuments endure through centuries, while our modern buildings crack after mere decades. Roman sanitation systems were centuries ahead. The Cloaca Maxima sewer network wasn't just an underground channel, but an integrated system with main and subsidiary lines, plus maintenance inspection ports. Public baths weren't merely washing facilities, but comprehensive recreational complexes, with gyms, libraries, even art museums. The hypocaust underfloor heating system revolutionized climate control, with hot air circulating through hollow floors and walls for perfect temperature distribution. In agriculture, Romans demonstrated brilliance matching their engineering feats. The villa farming system represented advanced scientific land management using crop rotation and innovative tools like wheeled metal plows. Water mills brilliantly combined hydraulics and mechanics, efficiently grinding massive grain quantities. For growing cities, Roman maritime technology was astonishingly sophisticated. Ostia's massive port employed special underwater concrete techniques. Ships featured advanced sailing systems including primitive astronomical navigation and sophisticated sail mechanisms. Commercial and military fleets became vital arteries, connecting the vast empire's extremities. Mining saw advanced Roman techniques surpassing contemporary knowledge. Rio Tinto mines in Spain implemented sophisticated water drainage and tunnel lighting systems, plus advanced smelting and refining methods. Mining tools underwent continuous improvement for increased productivity. Roman medicine achieved remarkable progress, particularly in surgery. Discovered surgical instruments reveal manufacturing precision and mechanically advanced designs. Medical texts by Galen remained European medical references until Renaissance times. Roman measurement systems established foundations for modern standards. Units like the Roman foot and Roman mile were calculated with extreme precision. Surveying, tools like the groma and water levels ensured quality control in massive projects. Daily Roman technology was remarkably advanced. The cursus publicus postal system could deliver messages across the empire up to 800 kilometers daily using relay stations. Glassmaking achieved breakthroughs producing transparent glass en masse, while glass-blowing innovations created affordable vessels for common citizens. In arts, Romans developed advanced mosaic and fresco techniques. Their fresco pigments maintained vibrancy for centuries through special chemical compositions. Sculpture reached unprecedented anatomical precision and expressive detail. Roman education followed structured curricula using innovative tools like wax tablets and scrolls. Great libraries like Trajan's implemented sophisticated manuscript cataloging systems. Entertainment architecture achieved engineering marvels. The Colosseum's 50,000-seat capacity featured integrated vomitoria passageways, preventing congestion. Advanced acoustics and lighting ensured optimal spectator experience. Legal and administrative technologies laid modern foundations. Documentation systems used wax seals and advanced classification. Textile factories, gynecia, mass-produced, high-quality wool, linen, and silk fabrics. Food preservation innovations included pickling, drying, and smoking. Granaries, horea, featured advanced ventilation preventing mold. Musical technology produced complex hydraulic organs, while musical theories influenced later systems. The Julian calendar achieved such precision, it became the Gregorian calendar's basis. Defensive structures like Hadrian's Wall incorporated watchtowers and rapid troop movement systems. Ceramics saw advanced terra sigillata, decorated pottery production. Chemical industries developed soap, dye, and perfume recipes. Early banking systems used deposit certificates and interprovincial transfers. Roman mathematics developed practical applications in construction and trade. The calculi abacus simplified complex accounting calculations. Animal husbandry employed selective breeding and veterinary care. Firefighting vigils units used primitive water pumps and early warning systems. Papyrus processing enhanced durability. While the codex format pioneered modern books, military signaling used smoke and light for rapid long-distance communication. Jewelry achieved exquisite goldsmithing with gemstone inlays. Theaters featured complex scenery-changing mechanisms and actor elevators. Weaponsmithing developed advanced metal hardening techniques. Diplomatic technologies included precise treaty systems and meeting translation protocols. Military footwear, caligae, and chainmail balanced protection and mobility. Urban planning employed Hippodamian grid systems with integrated water and sewage networks. Household tools displayed ergonomic and aesthetic design. Price control and quality assurance systems established measurement standards. Furniture achieved comfort and decorative excellence. Gymnasiums and pools featured innovative winter heating systems. Surgical tools demonstrated precision still recognizable. Today, census records maintain detailed population statistics. Water clocks, clepsydre, provided accurate court and bathhouse timekeeping. Environmental laws protected forests and mining areas. Board games and mechanical dolls provided home entertainment. Latin language education developed systematic grammar instruction. Writing tools included metal-nibbed stylus pens and wax tablets. Psychological crowd management informed amphitheater design. Hunting employed advanced nets and meat preservation. Ceremonial technology featured decorated floats and large musical instruments. Construction tools specialized for carpentry and architectural drafting. Media systems used public inscriptions and town criers. Maritime rescue developed primitive lifeboats and flotation devices. Early marine insurance protected against storms and piracy. Precise measurement tools included rulers and water levels. Cosmetics utilized herbal compounds and aromatic oils. Pharmacy employed precise measurement scales and compounding tools. Music therapy explored melodies' psychological effects. Folk arts preserved regional traditions. Indoor games and musical gatherings provided home entertainment. Meteorological tools enabled basic weather prediction. Food preservation used salt, vinegar, and fermentation. Personal hygiene tools included primitive nail clippers and toothbrushes. Evening entertainment featured poetry and music with oil lamp lighting. Gardening tools specialized for pruning and planting. Seasonal festivals followed precise agricultural calendars. Art tools included paintbrushes and mineral pigments. Vocational training maintained craft quality across generations. Home pharmacy provided basic remedies. Military music communicated standardized commands. Religious amulets and rituals offered spiritual protection. Winter entertainment featured indoor games and heated lighting. This monumental technological legacy didn't disappear with the empire's fall, but continued influencing subsequent civilizations. Today, in our age of advanced technology, we still regard these Roman achievements with respect and admiration, foundations for much modern technology. It's an invitation to rediscover this great heritage not as past history, but as inspiration for our technological future. The architectural achievements of the Romans, an epic of immortality in stone and concrete, at the dawn of Western civilization. As Rome wove the fabric of its vast empire, an unprecedented architectural genius emerged, embodied in towering monuments that still stand proudly across the centuries. The Romans transformed architecture from mere construction into a language of power and civilization, where engineering brilliance and artistic beauty merged in breathtaking harmony. Every stone laid, every arch raised, bore witness to the greatness of a civilization that could harness nature for its purposes and etch its name into the annals of history. In the streets of ancient Rome, where the chariots of nobles traversed granite-paved squares, the Colosseum stood as a stone giant, a testament to unparalleled mastery. This monumental structure, built by the Flavian emperors, was not merely an entertainment venue, but a meticulously designed architectural machine that encapsulated an entire philosophy of engineering, society, and politics. Beneath its vast vaults, the cheers of excited crowds mingled with the cries of gladiators, while precise engineering systems ensured the smooth flow of tens of thousands of spectators. The Colosseum was truly a theater of Roman life in all its contradictions, where cruelty met beauty and bloodshed met art. The Roman genius was not limited to grand public buildings, but extended to temples that embodied the connection between earth and heaven. The Pantheon, in its majestic grandeur, remains an architectural marvel defying time. This structure, combining external simplicity with internal magnificence, features a dome so vast it seems like a piece of the sky itself. The central oculus, allowing sunlight to stream in like a divine beam, stands as one of the most awe-inspiring architectural solutions in history. In this monument, Roman engineers achieved what other civilizations could not: a perfect harmony of durability and beauty. The network of aqueducts reveals yet another dimension of Roman brilliance. These channels, carved into rock and spanning valleys on towering arches, were not merely engineering projects, but the lifeblood of the empire. The Romans understood that water meant civilization, so they devised an intricate system to transport it across vast distances with astonishingly precise gradients. Structures like the Pont du Gard in southern France remain standing as testaments to boundless ingenuity, where builders combined strength and elegance in equal measure. Roman roads were no less significant among these achievements. This vast network, connecting the far reaches of the sprawling empire, was the backbone of Roman control. They were not mere dirt paths, but masterfully engineered works composed of multiple layers, designed to drain water and withstand the ravages of time. The Appian Way, with its meticulously laid stone paving, still tells the story of Roman determination to bind the world under their rule. Roman public baths represent another chapter of architectural grandeur. They were not just places for bathing, but fully integrated cultural and social complexes. The baths of Caracalla, with their imposing vastness and advanced hypocaust heating systems beneath the floors, demonstrate how the Romans transformed the simplest daily needs into opportunities for luxury and comfort. Their hypocaust system, an innovation for underfloor heating, remains proof of an ingenuity that was centuries ahead of its time. Roman markets, particularly Trajan's market, showcase further brilliance in urban planning. This multi-level commercial complex, with its vaulted arcades and orderly shops, was a fully integrated shopping center ahead of its era. The Romans understood that architecture must serve people's daily lives, creating spaces that balanced function and beauty. Triumphal arches, like the Arch of Titus and the Arch of Constantine, reveal how the Romans used architecture as a language of celebration and reverence. These structures, blending sculpture and engineering, were not mere gateways, but stone pages recording imperial victories and immortalizing glory. The intricate details of the reliefs and statues adorning these arches demonstrate the Roman commitment to uniting power and art. Roman domestic architecture was no less impressive. Lavish villas, such as Hadrian's Villa in Tivoli, displayed refined taste in merging architecture with nature. These expansive residences, with their hanging gardens and spacious halls, were models of opulence that Europe would not see again for centuries. Theaters, like the Theater of Marcellus in Rome, embodied the Romans' deep understanding of acoustics and visibility, with semicircular seating ensuring perfect sightlines and sound for all spectators. The greatest innovation enabling these achievements was Roman concrete. This magical mixture of volcanic ash and lime allowed them to construct massive domes and towering structures. This concrete, with its water resistance and exceptional durability, was the secret behind the survival of so many Roman monuments to this day. Roman architecture was not just about buildings, it was a philosophy of life. The Romans understood that structures must serve the people, express the state's power, and defy time. Through a blend of engineering innovation and artistic beauty, they created an architectural legacy that became the foundation of later Western civilization. These monuments that still stand today are not mere ruins. They are messages from the past, telling us of a civilization that left its mark on the face of history forever.